Hello. The workshop this week is all about creating something like a Rolodex, which is going to keep track of all your contacts. Now, there's a lot of new concepts and ideas we have to use in this workshop, and I want to show you these by going over a similar problem, which is going to keep track of a library of books. The idea of contacts and books are really not that much different, other than the information we store is totally different. So I've written a little program here, and I'll go through it. First of all, I have to include the usual studio or standard IO, and then I want to include string.h. I'm going to include string.h because I'm going to have to compare two strings, and there's a function in there called string compare that I have to use for that. So I want to explain that as we go along. I define the maximum number of books to be 100. You can make whatever size you think is needed. It may well give you a good idea in the problem statement. And then I create a structure to represent all the information in my book. Now for my book, I said all I've got is a title. You're going to have more information in your structure, but I'm trying to simplify this for the example. Down here, I create an array of 100 of these structures, and I initialize them all to be 0. I can set them to be 0 because one of the things you might have remembered when we talked about strings was that the string terminator was actually not only \0, but that was the number 0. So what this is going to do, it's going to put a string terminator at the start of every string in the title of the book. And that's going to initialize everything to be empty strings, which is a neat little trick we can do. Now I'm going to go into a do loop where I ask it to do one of several things. First, within this do loop, I'm going to print a menu. And it's going to say enter your command, 1 if you want to add a book, 2 if you want to show the books, 3 if you want to find a book, and 0 to exit. I scanf the command, and then I'm going to do a switch based on the value of the command they enter. If you put in a 0, that simply says we're going to leave, and I type bye-bye, and that's it. If I want to enter a book, I say enter the title of the book, and then I do the scanf. Now there's an extra %star.c right at the beginning, and I went over that the other day. You might remember that we just read a number, which was a command. And when we read a number, it leaves that new line character on the end of the previous line. So what we can do is we can use the %star.c, which will read one character and throw it away. %c reads one character, %*c reads that character and throws it away. The remaining part of this says %, and then they've got a regular expression which says not \n, which says read any series of characters which is not a new line, and then put it into library sub numbooks.title. Now I laid out space for 100 books. I'm going to be counting my way through, and numbooks was initialized to 0 up above, and I'm going to read it into numbooks.title. Notice that because that's an array of strings, I don't have to use the ampersand in front of it. After I read that in, I increase the number of books by 1, and I've added a book. Now, if I have to list all the books, this is the simplest case, and this is what you're going to be doing in the in-lab version. All you do is run a loop for I equals 0, I is less than numbooks, I++, and we print out library sub i.title. We can use a standard %s because it's stored as one string. The reason we had to do this not \n up there is because if we did a %s up there, it would stop as soon as it found a space. So if you had spaces in the title of your book, it would stop at the first space. So that tells it to read everything, including spaces. But once it's stored in a string, a space is the same as any other character, so we can just use %s to print it out. So that'll print out everything we have. Finally, I've got this idea that if you want to find a book, I say enter the title, I read it using exactly the same technique I used before. getting rid of a new line on the end of the command number, and then reading everything up to the end of the line, including spaces, into an array of characters called temp string. Now I'm going to do the linear search. And this looks exactly like the linear search we did last week. So I start a position out at -1, which means at the end of this, if I don't find it, position will be at -1, which is not a valid subscript. So subscripts always go from 0 up. -1 can never be a valid subscript. So if I do find it, I'm never going to set it to be -1. Therefore, I can use this to determine whether I find it or not. Okay, now I'm going to go through all of my books. Now what I'm actually going to do here is I could use Maxbooks or I could use NumBooks. Probably NumBooks would be a better way of doing it. So let's just say NumBooks. And it's going to compare using strcmp, which is the built-in function to compare strings, library I dot title with the temp string I just put in. And if they are identical, it will return 0. So I check to see if it returns 0. If it returns a negative number, it means the title is alphabetically less than the temp string. If it returns a positive number, it means the title is greater than the temp string. But if they're equal, it returns 0. So I say if 0 is what's returned by string compare, I remember I found it in position I, which sets I to be something greater than -1. And then to make sure that I don't keep searching forever, what I do is I set I to, actually I can just set it to be NumBooks now. And because this will stop as soon as it hits NumBooks, by setting that to be NumBooks, I kick it out of the loop a little early. Now I've finished the end of that for loop, which has done the search. I check to see, is my position greater than 0? If it is, I say I found it in that position. Otherwise, I say I could not find it, and I print out the temp string. So that is my little program. I will run it for you just to prove it works. So let's start without debugging. Okay, so I want to add a book. The art of a deal. Add another book. Okay, list my books or show my books, number 2, and it prints out there's the 2 books I have. Finally, I would like to find a book in 3, and the art of a deal, and it says that is in position 0, which is correct. So everything works. I do a 0, and it exits my program. So this is similar to what you're going to have to do for the first part of the lab. Now in the second part of the lab, they want you to be able to delete contacts that are already in your list. So I want to show you how this works. And I'm going to show it as a picture. Now, let's say that this is our array of books, and I've got 3 books in there. So this is my big array here, and I've got book B1, B2, B3, and number books is currently at 3, which is fine. And what I want to do is I want to delete book B2. So because all I have stored on the books is the name, what I'm going to do to delete it, I'm going to simply turn that name into an empty string, because no book can have an empty string as its name. So I'm going to use that to represent that the book has been deleted. And I would like to delete this book too. So what I do, and I have an eraser here, I'll get my little eraser and I can erase that. And that'll show that it's an empty string. And then I want to set that down to be 2 to show that I have a number of books down to 2. Now at this point, I've got an interesting problem. If I'm trying to find all my books, let's say I'm trying to find B3, what I have to do is I have to say, okay, is this the title of B3? No. Is this the title of B3? Well, it doesn't have any title at all, so I just skip it. Is that the title of B3? Yeah, it is. So I found it. So whenever I encounter any of these empty ones in the middle, I just have to skip over them and not pay any attention to them, which means I'm continually looking to see if it's an empty one. Now, in your Rolodex, what you're going to do is you set their phone number to be 0, I think. No, that's not it. That was another program. Where did I put that? It was over here. And yeah, so here, okay, these are the employees. And it's kind of like a list of your employees. And what you can do is you can usually zero out their employee ID. And that's how you can detect whether they're there or not. And it tells you that somewhere, yes. Now, somewhere here tells you if you zero out the change value for, okay. Okay, what you're going to have to do is you're going to have to update an employee, which means you're going to have to find it, and then you're going to have to remove employee. And in the remove employee, which is, I think, number 4. Yeah, so in number 4, you're going to have to do a while loop that finds things. And once the number's found, then you're going to change it. And you're going to decrement the valid employee count by 1, but you're not going to reorder them. And that's what I'm trying to show you. You're going to actually set its employee ID to be 0, and you'll use that to determine that it's not there. Okay, let's go back to my picture here. And in the picture, this guy, which has a title, it doesn't have an ID, has an empty string, which means it's not there. So anything that's got an empty string, you're going to have to just skip over. But then, how do you know when you really hit the end? Well, there's a couple ways. First, you know that you can't go beyond the total number of books. Second, you could say, well, as soon as I had an empty string, that's the end. But that's not true, because you could have these empty strings in the middle. So what you have to do is you almost have to count the numbers. You either count the number of strings that are valid and make sure it doesn't go over the number of books, or you just go straight to the end and compare them all. So at some point, you're going to have to do a linear search to find the one to modify in your employee program, or to find the one to delete. So if I take a look at my code, I've got the linear search for my books up here. And this is why I'm doing this linear search. You're going to be using that not to find an employee, to print them out, but to find an employee so that you can either modify their information or to delete them. And then once you do a delete, your way of printing out all your employees is going to become more complicated, because you have to check for employees which are embedded in the middle, which don't exist. Then when you do an insert, all I did was I inserted right at the end. You're going to have to search for the first empty position, even though it might be between 2 existing ones, or it might be at the end. You're going to have to find the first empty position, and you're going to have to insert it in that position. So we go back to our little picture. You're going to say, is this empty? No. Is this empty? Yes. So this will become your first empty position right here that you'll be able to insert into. It's not a very good end. So that's your insertion position, which would be the first empty position. And so that's how you find where to do an insert after you've used this idea that your deletion is done by, oops, I erased my line. But your deletion is done by setting the ID of your employee to be 0. Okay, so that's about it. That should be everything you need to know to get started. Remember how the string compare works, and remember how you have to include string.h to do it. String compare comes from the string.h library, and you have to put it in. Don't forget to put in your CRT secure no warnings, because you're going to need that in order for scanf to work properly. So that's it. Everything you need to know about this week's workshop.